This is day 7 of Unit 9. We started today with this warm-up, so take a moment and do that now. Pause the video, try it, and then play to check your answers. So you're supposed to go to page 19 and use problem number 1. So find the probability of tails if you know yellow was chosen. Well, we already have the diagram from yesterday from page 19. So using that diagram, I'm looking for the probability of tails given yellow. So that means I have to figure out the probability of yellow first of all, because that's the given. So yellow, I look at my diagram and I find the spots where yellow is, and that would be yellow with heads, which is 1/5, or, so I'm going to add yellow with tails, which is 1/6. So looks like 30 would be our common denominator, so 6/30 plus 5/30 gives us 11/30. So 11/30 is the denominator because that's the given, yellow. So I'm going to put that in the denominator. And then the numerator is both of these events, the intersection, so tails and yellow. So I go to my diagram and I find the intersection between tails and yellow, and that is 1/6. So that's my numerator. So then 1/6 times 30/11 gives me, cross off the common factor, we're left with a 5, gives me 5/11. Next, from page 20, the chicken and the blue. So finding probability of blue given chicken, I need the probability of chicken first of all. So I'm going to go to my diagram, which again, we did that yesterday, and I'm going to find the spots where chicken is. So that's 1/4, or the other chicken is 1/6, so or means add, and getting a common denominator, so 6/24 plus 4/24 gives me 10/24, which simplifies to 5/12, which is going to be my denominator, because I want blue given chicken. So I'm going to go ahead and put in the denominator 5/12. So that's chicken. Now I need blue chickens in the numerator. So I go to my diagram and I look for the blue chicken, which is 1/4. And I'm going to go ahead and multiply that. So I have I have 1/4 times 12/5. I don't know why that's being difficult. All right, apparently I need to get my pen again. So that would be 3. So we have 3/5. So the answer for number 2 is 3/5. Okay, so today our notes were on pages 20, 21, and 22, so you're going to need to turn to that in your packet. And the first problem on page 21 talks about expected values. So I did give a definition of that. So expected value, you should have talked about that in geometry last year, so it's not a new term, it's just a review. Expected value is the amount, and amount could mean money or points, etc. Could be other things besides money or points, but the amount of money or points or otherwise that a person on average can expect to win in a game of chance. That's what expected value is. So that's what it is, and then we talked about how to find it. So how we find it is we take the probability of an event. So I'll just say event 1. And we multiply that by the value of that event. So the value of event 1. And then I just keep doing that. So I'm going to take the next event, the probability, and I'll just call it event 2. And I'm going to multiply that by the value of event 2. And once I do that, I'm going to add those, and I'm going to keep doing that. So there might be a third event, so I'd multiply that third event's probability by its value, and I would continue to do that until I've taken care of all of the different events. And then we add all of those products together. That is how we calculate expected value. Okay. Now, as I said, sometimes expected value will be points, sometimes it'll be money, it could be even other things besides that. The first problem we looked at with expected value is number 2 on page 21, and that deals with money. So when you're dealing with money, obviously you're going to have a dollar sign, and you'll round to the nearest cent if you need to. So number 2 says someone's playing a game and she rolls a 6, she gets $10,000, and if she rolls anything else, she wins 1,000. So find her expected value. Well, her expected value is going to be the probability of a 6, which is 1/6, times the value of getting a 6, which is $10,000. And then we're going to add on to that the probability of not getting a 6, which is 5/6, times the value of that, which is $1,000. And when I do that, I'm getting $2,500. So a person on average can expect to win about $2,500 in this game of chance. Okay. Now, the rest of the page 21, I just kind of had students work on during class, and then after some time to work on, we just went over the answers. So I'm going to just put up the answers here for those, and then if you have questions, you should see me outside of class. So B is just 1/64th. After you complete the area diagram, you'll have that probability. And again, all of these, B, C, D, and E, you have to do the diagram first. Okay, so after you've done the diagram, then you'll be able to answer that. And then C, what's the probability of winning anything? Well, it says that this game, if you match the amounts, you will win. You'll win that amount. So matching the amounts means like I'll get the $100 and then the $100 again, or the $10 and then $10 again. The spinner will land on that. That's what it means by match. So winning anything at all would be if it matches for the tens, so 10, 10, or the fives, 5, 5, or the ones, 1, 1, or the hundreds, 100, 100. So you're going to get those probabilities and you're going to add them together. So when I add 1/16 plus 1/16 plus 9/64 plus 1/64 and get a common denominator, and you're going to show all that work, the answer is 9/32 for part C. Part D is expected value, and we are talking about money in this problem. So you're going to calculate the expected value like we discussed here, and you're going to get $2.64. Again, if you have questions on any of these, see me in class or sometime outside of class. And lastly, if it costs $3 to play this game, is it worth playing? Well, we can expect to win 264 and we paid $3. So monetarily speaking, no, it's not worthwhile. Then lastly, we did talk about one other topic, and that is what is considered a fair game. A fair game is when the amount you pay to play equals the expected value. If the two amounts are not 100% equal, then the game is not considered fair. Now, you don't want to think about fair in terms of like it's fair for one party or the other. You wouldn't say it's fair for the person playing or not fair for the person who owns the game. You don't think of it that way. Fair just means they're not equal. It doesn't really matter who benefits or loses. It just is not fair if the two amounts are not equal. And if they are equal, then it's considered a fair game. So in this particular problem, we weren't asked this question, but if you had been asked, is this game a fair game, you would also say no, because we're paying $3 and we can expect to earn 264. Those two amounts are not equal. Therefore, it is not a fair game. It's also not worthwhile because the person won't make any money off of it. So it's not worthwhile, but it's not fair because the two amounts are not equal. Okay, so that takes care of page 21. We also did do some work on the next page, 22, in class. And I'll give some answers for those in class, so I'm not going to take time in the video to give answers for that. But you should also do page 22 for classwork for today. And then homework, anything you didn't finish up on 21, 22, I assigned for homework. And then on page 18, you're going to go back and do that one problem, number 3C, that we skipped the other day. That's on expected value. And also you're going to do pages 23 through 25. Tomorrow you'll have a short quiz, and then Friday you'll have a longer quiz in class.